Okay, so that's called deep learning for natural language processing, where we will mainly have the implementation of the NLP concepts which are covered this semester, and look at their implementation in neural network. Okay, neural networks which are deep neural networks, many neurons, many layers of neurons, and so on. Am I still audible at this corner? At that corner? Yeah. Middle, at the back, left, left row, at the back. Okay. So these are the two courses which are uh, kind of in a sequence. Okay. So in this course, our main goal will be to understand what is natural language processing after all. Okay. And what kind of concepts we need to understand, what are the algorithms behind them, and also what is the application, what is the importance of this field, and so on. Now, these are some of the course logistics. Lecture venue is this. This is called LA001. Okay, you are here now. This is the ground floor of the lecture hall complex, and it is opposite to the CSA building. Okay, we are just trying to locate ourselves, situating ourselves. The course website is very important. Okay, lots of information will be updated there. And in particular, all the course slides and recordings will be linked from the course website. So this course website is important. It will link slides, recordings, and so on. Lots of information will be continuously updated. The recordings and files will also be available in the Teams link. Okay, so Teams is also very important. So let me go to the course website. Okay, so this is the course website, CS626. This is running in autumn 2024. A very important information is here. The MS Teams code using which you will join the Teams. Okay, the Teams link for the course CS6262024. So this is 74M0VUK. Okay, this is 74M0VUK. Now, when you go to Teams, okay, you will get get a link. Join or create a Teams. Okay, so if you give the Teams code, then you will automatically become a member of the CS6262024 Teams link. Okay, and under Teams, you will have a button called Files, and under the Files, you will have slides and recordings. These are already set up now, right? Maybe I can show it to them. Files, yeah.
General.
Okay. Yeah. So under files, you can see there are two directories: lecture slides and lecture videos. Okay. So all these information will be kept in under files, and they will also be linked from the course website. Okay. Now, course material, this will keep getting linked as we finish the lectures. The slides are given to the teaching assistant team, and they will link it from the website, and they will also be on the Teams link. Then a very important role will be played by our teaching team. Okay, so not everybody's name and picture appear here because the teaching team is still getting formed. So first name here is Shravanti, who is a PhD student. Shravanti, can you get up? This Shravanti. Okay, she is a PhD student. Nihar. Okay, then Arnav. He is an MTech second year student. Then we have Anuj, take second year student. Harsh Vivek. Harsh Vivek. He external. Oh, he's still not back to the campus. Okay. Then Sneha. No, Sneha has a different class. Ashray. Ashray is a PhD student. Then Satyam. PhD. Satyam is a PhD student again. Yeah. And there will be addition to this team. More people will join. Now they play a very important role in this course. Okay, we'll try to assign a TA to a particular group of students, maybe 10, 20 students or so. This class size is very big. It's about 350 students now. Okay. Now they will be assigned to a particular TA, and you can talk to the TA for any kind of logistic problem, conceptual problem. You are, of course, most welcome to meet me also with your doubts. But the TA will play a very important role in your day-to-day activity with respect to the course. Okay. So did you get it? There are 2-3 important things with respect to the website. Information will keep getting updated there. Okay. Keep looking at the website all the time. On the teams, you can place your messages there, and they will be answered either by me or by the TA team. And there is this Teams code, okay, which is required to join this Teams link. You will require your IIT Bombay ID for joining the course, joining the team. And the slides and recordings will be linked from the website. This is a graduate course, and it is expected that all of you will be thinking deeply about the material in the course, and you'll be curious about what kind of research is going on in this field. So for that, you can look at my homepage, which is the second link, https://www.csciitb.ac.pb. Okay. And our labs homepage is www.cfields.iitb.ac.in. CFIELD stands for Computation for Indian Language Technology. So though the name is Indian Language Technology, and the focus is indeed a lot on Indian languages, but the issues which are discussed, the investigations that we do, applies to all NLP, lots of machine learning, and lots of AI. Okay. Moodle also will play a very important role in the course. You can log into Moodle with your LM credential and select the code CS6262024. All course-related notification will be notified via Moodle also. Okay, we'll be primarily using Teams, but Moodle also will be a platform for communication. Most importantly, Moodle will be the platform for your examination. Okay, quiz, midsem, endsem. A large part of these will be on Moodle. So be familiar with Moodle. I'm sure the students who are already in IIT Bombay, they know about Moodle, they have been using it. New students, get yourself familiar with Teams and also Moodle. What is the evaluation scheme? I think all of you would be interested in knowing this. The evaluation scheme, I typically follow this principle of 50% on understanding, 50% on doing. So understanding involves reading, thinking, comprehending. So this is tested by quizzes, midsem and endsem. Okay, so quizzes will have 10% weightage, midsem 15%, endsem 25%, tentatively. Okay, right now this is the plan. And NLP is an empirical discipline. It is an experimental discipline. So there you will have to implement things and do hands-on. So this will be through assignment. Assignments will carry 25% weightage, and 25% weightage will be on a course project. So course project, the typical expectation is to make one paper as the center of your research small research, okay, semester-long research, and implement that, show results. If you can add something to that paper, it will be highly appreciated. Okay. So, but of course, one paper will not be enough for reading. You will have to, substantiate these with lots of allied information. Particularly, you may have to go back to the references given in the paper. I would imagine that for many of you, this will be your first exposure to research. Okay. So the course is a graduate level course. You can say it is number 6. The subsequent course is number 7. So the expectation is that in this course, you do quite a lot of your own thinking, your own creativity, your own imagination. They will be very important for the course. Okay, of course, you'll have to absorb everything that is told in the class, but do add in terms of your own creativity. Now, therefore, you will have to look at papers published in journals and conferences. It so happens that in computer science, which is a very fast-moving field, and especially AI and machine learning, the most recent results get covered in conferences. Okay, so while journals give you more complete information and more, complete and finished piece of work, conferences point to state of the art and how the frontier is moving. So there are a number of important journals which I mentioned. Computational linguistics is the most prestigious in our field. It is from the MIT Press. Then natural language engineering generally publishes papers on large practical systems. Both these journals are quite difficult to get into. They require high quality work. The bar is high. Then Journal of Machine Learning Research, JMLR. This journal is quite popular because their turnaround time is guaranteed to be about a month. So within a month, the feedback on the paper comes back. Typically, journals turnaround time is very long. Neural computation also is a prestigious forum. And then there are IEEE transactions, ACM transactions, which are again important journals for our area. TACL, transaction of ACL. ACL is Association for Computational Linguistics. So this is also a prestigious journal for our area. Now, conferences are extremely popular and extremely competitive. Many times the acceptance ratio is in the range of 20%. Okay, so if 1,000 papers are submitted, which is typically the case, some 200 get into the conference. Now, all these conferences, ACL, EMLP, NACL, EACL, AACL, NeurIH, ICML, UAI, Uncertainty AI, AI Statistics. So these are very prestigious forums where you will get a high quality work described. And it so happens that in many of the offerings of this course, as well as CS726, which is the subsequent one, one or two course projects have been absolutely spectacular. And many times they have been published in one of these fora from the course project. Okay, so this means that some of you really get excited and enthused by the field. And once the foundation is laid in the class, you begin to think about new ideas, you become creative, which is extremely welcome. Okay, and that's very satisfying both for the professor and the students. There are many useful NLP, machine learning, and deep learning libraries, which will be very useful to you. NLTK is from Australia by a professor called Stephen Bard. His contribution is really very noteworthy because he made lots of tools, resources in language processing available to the researchers, completely free of cost, fully open. Okay, so NLTK has been used by NLP researchers at least for last 20 years or so. Scikit-learn is for machine learning. All kinds of machine learning algorithms are implemented there, completely open source too. For example, support vector machine, the implementation is very good there. PyTorch, TensorFlow, Hugging Face, these are deep learning platforms. Okay, I'm sure many of you have been already using them. And from Hugging Face, you have possibly downloaded data, tools, okay, models, especially models. So these are important tools and platforms for us. Spacey is again NLTK. Lots of NLP algorithms are implemented there with open code. Stanford Code NLP has been a well-known platform again for deep learning for NLP systems. And our lab also has contributed tools, resources, and so on. There are many interesting demos on our lab homepage. Okay, so these are sources of information and also tools and techniques. Also, I should not forget, there is a nice forum. It's called Papers with Code, okay, which is very useful. Papers with Code. Okay, very useful. And another forum which I should add here is SCL and Anthology. This has archived lots of papers in natural language processing. They are all peer-reviewed, high-quality papers. Okay, so this is by way of places where you should look for information. Okay, any question on this? This will be your bread and butter, your friend, okay, going forward. Okay. Now let's get into the subject matter. And let me begin with this equation. NLP equal to language plus computation. Okay. We try to build systems which implement language related tasks. Okay. So what are they? As we move forward, we'll see what they are. So NLP is language plus computation. I would like to now play a 10-minute video. Okay. Allow me to play it to you and just patiently listen to it. There will be some terms like statistics, distribution. These are applicable to natural language processing. So this video is called The Linguistic Genius of Babies. Okay, how small children, babies, begin to acquire language. And if you think about it, our job is also similar. For us, the babies are the computers. Okay? And we would like to give them language abilities. But there are extremely intriguing and interesting ways in which human beings and computers differ in learning of language and using of language. Okay. Now you see, look at this video, listen to this video, and see how the word training comes in, distribution comes in, statistics comes in. So this is a 10-minute video. Okay, please pay attention.
But today I'm going to talk to you about something you can't see. What's going on up in that little brain of hers? The modern tools of neuroscience are demonstrating to us that what's going on up there is nothing short of rocket science. And what we're learning is going to shed some light on what the Romantic writers and poets describe as the celestial openness of the child's mind. What we see here is a mother in India, and she's speaking Koro, which is a newly discovered language. And she's talking to her baby. What this mother and the 800 and the two babies And therein lies a critical puzzle. Why is it that you can't preserve a language by speaking to you and I, to the adults? Well, it's got to do with your brain. What we see here is that language has a critical period for learning. The way to read this slide is to look at your age on the horizontal axis. We've done it. And you'll see on the vertical your skill at acquiring a second language. The babies and children are geniuses until they turn 7, and then there's a systematic decline. After puberty, we fall off the map. No scientists dispute this curve, but laboratories all over the world are trying to figure out why it works this way. Work in my lab is focused on the first critical period in development, and that is the period in which babies try to master which sounds are used in their language. We think by studying how the sounds are learned, we'll have a model for the rest of language, and perhaps for critical periods that may exist in childhood for social, emotional, and cognitive development. So we've been studying the babies using a technique that we're using all over the world in the sounds of all languages. The baby sits on a parent's lap, and we train them to turn their heads when a sound changes, like from ah to e. If they do so at the appropriate time, the black box lights up and a panda bear pounds a drum. A 6-monther adores the task. What have we learned? Well, babies all over the world are what I like to describe as citizens of the world. They can discriminate all the sounds of all languages, no matter what country we're testing and what language we're using. And that's remarkable because you and I can't do that. We're culture-bound listeners. We can discriminate the sounds of our own language, but not those of foreign languages. So the question arises, when do those citizens of the world turn into the language-bound listeners that we are? And the answer, before their first birthdays. What you see here is performance on that head turn task for babies tested in Tokyo and in the United States, here in Seattle, as they listen to ra and la, sounds important to English, but not to Japanese. So at 6 to 8 months, the babies are totally equivalent. 2 months later, something incredible occurs. The babies in the United States are getting a lot better. Babies in Japan are getting a lot worse, but both of those groups of babies are preparing for exactly the language that they're going to learn. So the question is, what's happening during this critical 2-month period? This is the critical period for sound development. What's going on up there? So there are 2 things going on. The first is that the babies are listening intently to us, and they're taking statistics as they listen to us talk. They're taking statistics. So listen to 2 mothers speaking motherese, the universal language we use when we talk to kids, first in English and then in Japanese.
Ah, I love your big blue eyes. So pretty and nice. うわー、大きな茶色いお目目。そして綺麗な黒い髪。
During the production of speech, when babies listen, what they're doing is taking statistics on the language that they hear. And those distributions grow. And what we've learned is that babies are sensitive to the statistics, and the statistics of Japanese and English are very, very different. English has a lot of R's and L's, the distribution shows. And the distribution of Japanese is totally different, where we see a group of intermediate sounds, which is known as the Japanese R. So babies absorb the statistics of the language, and it changes their brains. It changes them from the citizens of the world to the culture-bound listeners that we are. But we as adults are no longer absorbing those statistics. We're governed by the representations and memory that were formed early in development. So what we're seeing here is changing our models of what the critical period is about. We're arguing from the mathematical standpoint that the learning of language material may slow down when our distributions stabilize. It's raising lots of questions about bilingual people. Bilinguals must keep 2 sets of statistics in mind at once and flip between them, one after the other, depending on who they're speaking to. So we asked ourselves, can the babies take statistics on a brand new language? And we tested this by exposing American babies who've never heard a second language to Mandarin for the first time during the critical period. We knew that when monolinguals were tested in Taipei and Seattle on the Mandarin sounds, they showed the same pattern. 6 to 8 months, they're totally equivalent. 2 months later, something incredible happens. So the Taiwanese babies are getting better, not the American babies. What we did was expose American babies during this period to Mandarin. It was like having Mandarin relatives come and visit for a month and move into your house and talk to the babies for 12 sessions. Here's what it looked like in the laboratory.
早上有气息在这里，绿色的圈圈，绿色的圈圈，绿色的圈圈，转转转一圈，嘿，一圈，再做转一记二。
So what have we done to their little brains? We had to run a control group to make sure that just coming into the laboratory didn't improve your Mandarin skills. So a group of babies came in and listened to English, and we can see from the graph that exposure to English didn't improve their Mandarin. But look what happened to the babies exposed to Mandarin for 12 sessions. They were as good as the babies in Taiwan who'd been listening for 10.5 months. What it demonstrated is that babies take statistics on a new language. Whatever you put in front of them, they'll take statistics on. But we wondered what role the human being played in this learning exercise. So we ran another group of babies in which the kids would get the same dosage, the same 12 sessions, but over a television set. And another group of babies who had just audio exposure and looked at a teddy bear on the screen. What did we do to their brains? What you see here is the audio result, no learning whatsoever, and the video result. No learning whatsoever. It takes a human being for babies to take their statistics. The social brain is controlling when the babies are taking their statistics. We want to get inside the brain and see this thing happening as babies are in front of televisions as opposed to in front of human beings. Thankfully, we have a new machine, magnetoencephalography, that allows us to do this. It looks like a hairdryer from Mars, but it's completely safe, completely non-invasive, and silent. We're looking at millimeter accuracy with regard to spatial and millisecond accuracy, using 306 squids. These are superconducting quantum interference devices to pick up the magnetic fields that change as we do our thinking. We're the first in the world to record babies in an MEG machine while they are learning. So this is little Emma. She's the 6-monther, and she's listening to various languages in the earphones that are in her ears. You can see she can move around. We're tracking her head with little pellets in a cap. So she's free to move, completely unconstrained. It's a technical tour de force. What are we seeing? We're seeing the baby brain as the baby hears a word in her language. The auditory areas light up, and then subsequently areas surrounding it that we think are related to coherence, getting the brain coordinated with its different areas, and causality, one brain area causing another to activate. We are embarking on a grand and golden age of knowledge about child's brain development. We're going to be able to see a child's brain as they experience an emotion, as they learn to speak and read, as they solve a math problem, as they have an idea. And we're going to be able to invent brain-based interventions for children who have difficulty learning. Just as the poets and writers described, we're going to be able to see out of things that wondrous openness, utter and complete openness of the mind of a child. In investigating the child's brain, we're going to uncover deep truths about what it means to be human. And in the process, we may be able to help keep our own minds open to learn for our entire lives.
Okay, so you heard this video, right? And you probably heard the word statistics many times. You heard the word distribution also. So now these things are seen in the context of language learning by baby.
It's not just a baby. There are other things like this. It's the weird open spaces, like reading open arts.
Okay, so we'll encounter these terms throughout this course and the next one. Distribution, statistics, probability, entropy, information, perplexity. Okay, so they will be very core terminology for us, along with the concepts from language science, okay, like parsing, sound, phrases, sentences, and so on. So it will be interaction between language science and data science. Now, going forward, yeah, what I wanted to say was, so you heard that when a particular language is learned, and beyond the age, learning another language becomes very difficult, right? The lady said this. The lady is Professor Poole, who is an internationally known expert for her work on child language learning. Okay? So now, when a particular distribution is learned from data and it is used to do inferencing on another distribution in data, this is known as transfer learning. Okay, and is a very important concept in machine learning. And if some of you have heard about GPT, okay, the pre-training systems, large language models, they get trained on massive amount of data, and we use such models for performing specialized tasks with what is called fine-tuning data, which is a small amount of data. So with this small amount of data, which is called fine-tuning data, we change, okay, or change the shape of the distribution or the position of the distribution. Now, you might be wondering why distribution, probability, statistics, data play such an important role in NLP. Okay, one of the reasons is that NLP is not an exact science. Okay, many possibilities exist. This is true about whole of AI, and we have to pick one of the possibilities as the best possible option. And this best, quote unquote best, is decided by most of the time by the highest probability option. So we have to model the probability distribution extremely well. So let's proceed towards that. Now let me talk about two foundations which pertain to language and also artificial intelligence. The first foundation is called Turing Test. This was proposed by the father of computer science, Alan Turing, in 1950. He called it an imitation game. And those of you who have gone through an AI course before or have been curious about AI, maybe a researcher in AI, have seen this kind of arrangement where there is an interrogator C interacting with A, which is a machine, and B, which is a human being. And if by this interaction, C cannot distinguish between A and B in terms of who is the man and who is the machine, then we say that the machine A has succeeded in the Turing test. Okay, succeeded in the Turing test. Now, this has been one of the cornerstones of the benchmarking for AI systems. What is not emphasized is the word in red, indistinguishable. Okay, we are never saying that the system A should solve all problems of intelligence. That is never the intention of this particular test. That's a subtle point and important point. All it says is that the distinguishability point is important. If you're not able to distinguish between A and B, then A succeeds the Turing test. Doesn't matter what the label is. If B happens to be a stupid person and A matches that stupidity, we say A has passed the Turing test, even though A is very stupid. Okay, so the point is indistinguishability. The other subtle point about Turing test is that since the emphasis is on distinguishability, the test need not be only based on language. It can be between a human being and a robot. Okay, so if the robot's performance is indistinguishable from the human beings, then we would say that the robot has passed the Turing test. So in this case, the test is not language based. The second foundation I would like to present to you is called Searle's Chinese room experiment. Here, what is happening is that there is a program which is interacting with a Chinese speaker. Okay, and this program has encoded in it all the rules of understanding the Chinese language, processing Chinese language. Should not use the word understanding. So it carries out a very meaningful dialogue with the Chinese native speaker, and the native speaker has an impression that it is interacting with a very intelligent being, okay, which is non-human but very intelligent after all. So this is questioned by this very eminent philosopher called John Searle. So he gave this experimentation or test in 1980, 30 years after the Turing test. Okay. So what he said is that there will be a human being which mimics this computer. The human being has no notion of how Chinese language operates. Okay, it will just mimic the program which interacts with the Chinese speaker. And now this human being will succeed in carrying out a meaningful dialogue with the Chinese native speaker. Now you ask the human being, do you understand Chinese? The answer surely will be no, because the human being was only mimicking the program. Now, Searle's argument was that if the human being, which is just simulating this program, or the program is again simulating a human being, if the human being says, I don't understand, then the program also doesn't understand. Okay. So what is the connection between Turing test and Searle's experiment? Both of them are based on language, you see. Is that in Turing test, we say if the machine passes the Turing test, the machine is intelligent. Searle says no. Okay, it is not enough, by which he shows by this experiment. Now both these tests, Chinese room experiment and Turing test, have been subjected to lots of criticism. I would like to encourage you to understand these two very fundamental experiments, Turing test and Chinese room experiment, and see their ramifications, subtleties, criticisms, and so on. Let's proceed. Now I decided to give a Turing test to chatgpt. Okay, so I gave this puzzle to chatgpt. So this text in red, they are the main points about this particular puzzle, let's say. So a ship was going from England to France and it was caught in a violent storm. So the ship got wrecked, and with a lot of difficulty, the captain of the ship, who fortunately survived, he had a binocular and he spotted an island at a distance. So he somehow got down at the island, saved himself, and slept for a long time. After that, of course, he felt very hungry. Fortunately, he had some potatoes with him. Then what he did was he lighted a fire and boiled these potatoes. Okay, so this fire was burning on sand. Then after eating, he slept again. When he woke up, he found some shining objects, okay, on the sand. And these shining objects he preserved with him. Then again, after several days, with his binocular, he spotted a ship. So somehow he attracted the attention of the ship. The ship rescued him and took him back to England. But he took these shining objects also with him. So when he went there, he gave these shining objects to chemists, and they identified interesting properties of for this shining objects. And they call these shining objects as glass. Okay, and this is the story of discovery of glass. So is this story correct? Is it consistent? No, why? Come again. Right. So how did the captain spot the ship, spot the island with binocular if glass was yet to be discovered? Okay. So there is a temporal inconsistency here. Now, what did ChatGPT say? ChatGPT said that there are several issues with this story indicating that it is not entirely accurate. Firstly, glass was not invented by a shipwrecked captain as described in the story. So ChatGPT is taking a different path, valid, but it misses the fact, right? So why is ChatGPT giving this answer? Because it has been trained on lots of historical data, which also includes the story of the discovery of glass. And see, ChatGPT takes a complete historical path. The history of glassmaking goes back thousands of years and it involves contributions of many different cultures. Fine. Secondly, the story implies that the glass is made from potatoes. So this, how did it get? This problem is called hallucination. In today's parlance, it is called hallucination. It is a mistake on his part. And again, why is it happening? Any guess? Why is this happening? The captain was unconscious. No. ChatGPT says that glass is made. The story implies that glass is made from potatoes. Where is this implied? Yeah, that's true. But why is it producing these effects? No, why amongst many possibilities, why did it produce? Yeah. So I think this is called chain of thought reasoning now. So there is a kind of chain of reasoning happening that the captain boiled potatoes, and while he was boiling the potatoes, these two events are simultaneous: appearance of glass and boiling of potatoes. So we know that not all correlations are causes, right? Correlation and cause, they look sometimes alike, but that is not the case. So in this case, somehow the correlation of two events, boiling of potato and appearance of glass, they have been correlated, and ChatGPT has gone one step further and established a cause and relationship between them. Okay, and then it is negating this because of its historical data. So all this is happening, and I think when you actually concepts by ChatGPT in the class. Okay, so it missed this point of inconsistency, temporal inconsistency. Okay. Anyway, so I would say that it did not really pass the Turing test in this case. Okay. Now let's go to some introduction and perspective. We have about half an hour left. So what characterizes human language? There has been inquiry into the nature of human language, which is at least 2000 years old. But there was in 1998 by George Yule, who is a linguist and a philosopher and cognitive scientist. He said that human language has these 6 properties. We will not elaborate them. Just mention them. Arbitrariness, productivity, creativity, cultural transmission, distinctness, and duality. The first property is extremely intriguing, at least to me. that human language has this unique property that you can talk about a time or a place without physically being present there at the time of utterance. Okay, so when I say I saw him yesterday at the market, and I'm also not in the yesterday. Okay, when I'm uttering this. So there are documentary proofs that animal communication lacks this property. Okay, one dog cannot tell another dog that chalo kal cinema jayenge. Most probably not. So animals typically live in the here and now. Typically. Okay, there may be exceptions, but yes. So this displacement pricing, the third property is very interesting. It is called productivity. From a finite number of rules and symbols, we can generate infinite number of sentences. Okay, so this happens due to what is called recursivity of recursivity. So the cat that spilled the milk, which was smelly, on the floor that was slippery, and you can go on and on, and at the end say fled. The main sentence is the cat fled, and in between you have all these phrases. The cat that spilled the milk, which was rotten, fled. You can keep on embedding sentences like this. This is called recursion. So for our course, the recursion is very important. We'll see how to model recursion. Okay, how do we capture recursion? This happens through the context-free grammar rules. Discreteness, sound and meaning units are separated. Automatic speech recognition has to be very sensitive to discreteness. The speech signal is continuous, but still we are able to identify word boundaries. You're listening to me, you're able to identify word boundaries, even if I do not give pause. And the pause can have very interesting effects. I don't know these 3 words, ao, mat, and jao. 3 words. Depending on the pause, the meaning completely changes. Ao, mat, jao. Come, don't go. Ao, mat, don't come. Jao, go. Depending on the pause, the meaning completely changes. And duality, now the very difficult problems of language processing, in which we have done considerable amount of research. So duality refers to the phenomenon of the surface meaning being different from the deeper meaning. Okay, so these are the properties of language which will be concerned with computation. Now there is this notion of language phenomena. So these are language phenomena. In German, if you want to form a question from a sentence, you have to bring the verb to the front. In English, you have to bring the auxiliary verb to the front. How do you form a question in Indian languages? Typically, you use some kind of WH word. I will go, will I go? But in Hindi, you will have to introduce some kya word. Okay? Kya main jaunga. Then there can be what is called semantic pragmatic incongruity, which is like circular. At the level of sound, we have this phenomenon called sandhi. For example, no and one produces none. The 2 sounds have fused together and produced a new sound. Now, language modeling has a few instruments, okay, conceptual instruments. The first instrument is what is called softmax function. It's a vector of numbers into a vector of probability values. Okay, so this is the softmax function. We'll have to make use of this as we move forward. So, for example, 1, 2, 3 is the vector of numbers, and you get 0.09, 0.24, 0.67 after applying softmax. So softmax is the first instrument. Second instrument is what is called the cross entropy loss, okay, or any kind of loss function. So language phenomena are modeled by softmax as an instrument, cross entropy loss as the second instrument, and then by what is called the gradient descent and backpropagation algorithm, okay, which changes the parameters of the machine learning model. Okay. I'm just giving you an overview of some of the important concepts. They will be illustrated and elaborated further. So nothing to worry about this terminology if you don't understand it. Okay. Now let's look at, we looked at nature of language and how language phenomena are modeled. Now let us see the nature of NLP. Natural language processing is the art, science, and technique of making computers understand and generate language. Okay, just like baby language acquiring, the machine also has to acquire language. And what are the techniques for doing so? So we know of three generations of natural language processing. The first generation was based on rules. So a person who is conversant with the language and also understand the task very well would sit down and write rules. So if you're creating a English to Hindi machine translation system, one of the rules which is very frequently used will be the verb will go to the end. Okay, Ram saw Sham. Ram ne Sham ko dekha. Saw, which is in the middle of subject and object, has moved to the end. So this kind of rule is written by human beings. In the second generation of NLP, we made use of data and statistics, statistical machine learning. So things like hidden Markov model, support vector machine. So our first after this introduction will be hidden Markov model based part of how to using this will be continuously in the course. We'll look at some technique like hidden Markov model and take some language task which is solved with that technique. In the third generation, deep learning came and all the NLP tasks migrated to a neural network based system. And here the neural networks are made to compute probability by applying the softmax function. Those probability values are made use of to solve any kind of NLP task. And the most modern approach to NLP and also many AI tasks is large language model based. Okay. So in the course also we will continuously refer to large language modeling based solutions or give examples of large language modeling. For us, fortunately, this task is easier now because of the chatgpt. So chatgpt is based on large language model. And we'll show that the chatgpt is able to solve many of these NLP tasks, which we will first understand and give some algorithm to solve. So today's NLP framework is typically LLM and generative AI based. But we need to look at the whole sequence of many different approaches to this task, solving this task to understand what this task involves. So the two pillars of NLP are language science, also called linguistics, and data science, which is probability, mainly probability. Okay, so this is my picture, which I am very fond of using for any kind of discourse on language. So, how does linguistics play a role? Most of the NLP systems these days are based on machine learning. Machine learning requires what is called annotated data. Okay. For example, you will do a small assignment and statistical part-of-speech tagging. So you will see that part-of-speech tag data, which is raw text and part-of-speech information, noun verb. those levels or annotation of the data, enrichment of the data comes from inside. And linguistics also plays its role after we obtain the results from the machine learning model. To understand what is going on, we again need linguistic insight. What is the role of probability? Probability makes use of two important laws. The first law is called law of large numbers. So when we say the probability of seeing a noun after an adjective, most of the time we see adjective in a noun after an adjective, right? So if I say that the probability of seeing a noun after adjective is 0.8, then one might come back and ask me, based on what do you make this assertion? I would say that it's based on data. Then my opponent would say that that's not enough. How much of data? Okay, so this is based on the law of large numbers. The statement intuitively is that as the data increases, the confidence on the probability values also increases. Okay, the statement is much more formal, involves epsilon, etc. But this is roughly the idea. The second one is very intriguing. You can have data of all kinds. So suppose you have been asked to create a chatbot for State Bank of India, okay? Or let's say Indigo Airlines. And then you want to know what is the distribution of language phenomena in the data given by the insurance company or Indigo Airlines company or State Bank of India. Very difficult, okay? But the second theorem says that doesn't matter. You don't have to worry. It's called central limit theorem. It says that as long as the data crosses a threshold, typically 30 instances, you can approximate any distribution by normal distribution. And the moment you are allowed to do so, you'll be able to make use of the whole powerful machinery of normal distribution. In particular, you can do hypothesis testing, okay, based on normal distribution. So we'll definitely spend some time on how to do hypothesis testing. We can make all kinds of claims about machine learning models, applied to NLP, applied to robotics, anything. But these claims have to be well established. Okay, so that can be done by making use of hypothesis. The law of large number and central limit theorem are going to be our friend as we move forward in the course. The main challenge of natural language processing is ambiguity. Here I give a sentence which is artificial. Okay, it is given by linguists. This sentence has 1, 2, 3, 4, 5, 6, 7, 8. 8 buffaloes in the sentence. One might think that does this sentence mean anything? It is possibly a nonsense. Okay, the sentence is buffalo, buffaloes, buffalo, buffaloes, buffalo, buffaloes, buffalo, 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 buffaloes. Does it mean anything? Okay, so it means something. And I gave this sentence to ChatGPT. What do you understand by this sentence? The answer is very nice. It says Buffalo as a noun refers to the city of Buffalo, which is in the state of New York in the United States. Buffaloes is a verb, means to bully, to confuse or baffle. Buffalo as a noun has another meaning. It refers to the animal, specifically the American bison. So ChatGPT says this. It describes a scenario where bison from buffalo are being intimidated or confused by other bison from the same place, who in turn are intimidating or confusing other bison. It's a playful sentence that plays on the multiple meanings of the word buffalo as a place. And this is correct. If you are wondering how did ChatGPT decipher this sentence, which is very difficult even for human beings. I don't know how many in the class got the meaning of this sentence, unless you have seen it before. Very unlikely that you have been able to get the meaning in the first book. But ChatGPT gave this answer. The simple answer to this is that ChatGPT has seen this in the training data before. Okay, so maybe somebody has described this sentence maybe in some linguistics course. In my NLP code, I have shown this sentence. So ChatGPT has ingested all this, trained on this, and has given answer. What is not trivial is these very nicely formed sentences, the whole discourse which comes out of ChatGPT. Absolutely grammatical sentences, very coherent paragraph, which has been the success of generative AI or generative NLP, okay, natural language generation. So another ambiguity which we saw today. I don't know how many of you read the Times of India today. Look at this headline. Is it? You see the play of words there. What is the context? The bronze medal that was won by Manu Bakhe. I suppose I am pronouncing it bad. So you should not pronounce this as manuscript, but as manuscript, right? Manuscript. This is again a play of words, and it is making use of ambiguity. So headlines do this. They want to catch the attention by playing on the words. So ambiguity is inherent in language, and we create machine learning models which can disambiguate by choosing amongst ambiguous options, multiple options, and that it does by making use of data and probability. So would you like to say that let's make our life easy. Let's make natural language processing easy, AI easy, by removing all ambiguity from the word. Would you like to do that? No? Why not? If you do so, then such things will be impossible. Okay, the beauty of expression through language, a lot of that beauty will be lost. Let's end with a small discussion on language modeling, which will occupy our attention quite a lot. Next about 5 to 7 minutes. Language modeling. So language modeling is a modeling task. And we would like to first observe that for any modeling task, the main goal is prediction. Okay, models have to predict. That is their success. So this equation, maybe you have seen quite a lot in your physics classes, mechanics classes. X equal to ut plus half at square. So from this time, if I know the duration, the acceleration, and the initial velocity, I can predict the distance covered by the particle. This prediction, okay? But it is expressed in the form of a very crisp equation. That is not the situation. This happy situation doesn't exist for language. Okay, language models also predict. What do they predict? They predict the next word, only that, or they predict the property of the language. So this discussion is very important and a cornerstone of NLP these days. So it predicts the next word. So suppose you ask this question to ChatGPT, what is the capital of India? It is extremely good in answering such questions. It will say Delhi. Now you will have to take my word when I say that the word Delhi is coming as a fill in the blank task. Okay, the situation is this. You have seen this words. What is the capital of India? Predict the next word. It will predict the next word as Delhi. It is not doing question answer. It is predicting the next word, which is different from saying that this question is understood by ChatGPT. It understands Delhi. It understands capital. It understands India, and therefore it is able to answer Delhi. So this method of understanding is very different from the way we will answer Delhi. Or is it? Are we also doing fill in the blank and completing the next piece of text? Are we also? Something to be thought about, a very deep question. takes us to this Chinese room experiment of CERN. Okay. Even summarization. If I give you these sentences here, you have probably read these sentences and ask ChatGPT to summarize this. It is extremely good at this. It will produce a summary. Delhi is a large population busy city, which is a very good summary of the input text. And we would again like to say that ChatGPT doesn't understand what is summarization. It is only predicting the next word at different time steps. Okay. So having seen these sequence of words, Delhi is a large city up to activities and new models, the next most probable word, the word that meets the probability distribution, is Delhi. Okay. Then the next word, most probable word is E, then it is A, then it is large, and so on. And ChatGPT is giving an impression of understanding the input text, understanding what it means to summarize, and gives the summary. It gives that impression. Next obvious question is, do we also give an impression when we summarize text? Okay, a very intriguing and deep question. Are we also sampling from probability distributions? May be true. If you have heard this Professor Poole's lecture, did you notice how many times she said statistics and distribution? The child probably acquires a probability distribution and is trained to sample from that probability distribution. There is no more magic in this. Okay, if we say this, then the cognitive scientists, philosophers, linguists, social scientists, psychologists, political scientists, physicists, chemists, they'll come back and tell me and others who believe in this that please go away. Don't tell me that all we do is sampling from probability distribution. Very, very important statement. All we do and anything we do is just sampling from a probability distribution. Then we need to understand the probability distribution carefully. And from the data, we have to get the probability distribution accurately. So does it mean that we don't need any linguistics, we don't need any sentiment, emotion, understanding, nothing, no cognitive side? We have to only understand data and probability. Is that the right position to take? No. No. As we go ahead, we'll see. Okay. We need those other things also, in fact, those deep things also. And the language model also predicts the properties of the input object, which is an input text. So this prediction of the property is called classification or regression. For example, sentiment analysis. The movie was wonderful. You ask ChatGPT, what is the sentiment in? The movie was wonderful. It will say positive. Again, a fill in the blank is happening. The word positive, P-O-S-I-T-I-V, is sampled from a probability distribution, which is the highest conditional probability after seeing these words. Okay. Again, sampling from a probability distribution. So this is very intriguing. If you think about this, we are all the time sampling from a probability distribution. Not we, the NLP systems. And then there is this intricate, use of linguistics, philosophy, cognitive science, physics, maths, and so on. Lots of maths. Okay, so let's stop here, and we'll continue the course in this vein. A few important points. Okay, so not all lecture will be completely absorbing, interesting.